Hello, welcome to the course Core Pure Year 2. So on this course, which is going to be I don't know, approximately 70 videos or so, we're going to go through all of the Core Pure content for the A-Level in Further Maths. This is A-Level Further Maths that's taught in England. It's English qualification. It's a level 3. It's a second A-Level in Mathematics, and this is the second year of that course, and it's only the compulsory content. Okay, so this is the compulsory content of Core Pure in Year 2. We will have a focus on the MEI specification in most of these videos, but a lot of the content will be relevant across other exam boards as well. And in this video, I just wanted to give a very quick overview of everything that's going on in this course. And you can just jump straight into other chapters throughout this course as you need to. Okay, and if you have questions, please at any time just drop any questions in comments as you watch my videos. So we start the course with a little bit of something that we did in Year 1. So Year 1 Core Pure, we did some proof by induction. We do a little bit more proof by induction in Year 2. So we introduced divisibility results, which essentially asks us a question, when is this expression divisible? Or prove that this expression is divisible by a certain number. And then we also have some calculus results as well. These are quite rare on the MEI course. They can be quite difficult, but I have seen an exam paper question that contains one. So I do a video on one of those. So do check that out. That'll be the first topic that we look at. There's about 3 videos in my proof by induction section. After proof by induction, we jump into complex numbers. This is another topic that was taught in year 1 Core Pure. We take it a little bit further. The main focus of this is something called De Moivre's theorem, which looks at raising complex numbers to powers, and we're able to use the properties of De Moivre's theorem to prove some trigonometric results, which are very real, and we look at summing trigonometric series as well. It's quite an interesting topic, but it does ramp up in difficulty compared to the Year 1 content. But lots of interesting things in complex numbers. Polar coordinates then is after that. I haven't done that series quite yet at the recording of this video. That's going to be my next task. That's probably going to be half a dozen or so videos. And polar coordinates is essentially another coordinate system. So not your standard XY coordinates, which is what we call Cartesian or rectangular coordinates. But instead we use something called r theta. And instead of measuring how far across and how far up you move to get to a point, you measure how far away from the origin or the pole you are and how far round from the positive x-axis you go. With polar coordinates, we were able to create some more interesting shapes and analyse those. And we look in particular at shapes like the rhodonia, so it's a little bit of a flower. It's not a great rhodonia, that one. They're all supposed to cross at the same point. But yeah, essentially a spirograph shape. That's one with 3 petals, but you could have one with 5 petals, which is not going to go well, but there you go. We look at shapes called cardioids, which kind of look like that, related to the name of a heart. It's not quite heart-shaped, it's a bit rounded at the bottom, but we study those. And then a more general cardioid, or cardioid is part of what we call the limacon family, which can kind of dimple, or it can go and loop. So yeah, lots of interesting shapes that we study in the polar coordinates chapter. So do check that one out. In the series chapters, we have a few different topics kicking around. We have got method of differences. So there was some series taught in Year 1 Core Pure. So there's a couple more topics that are taught in Year 2 Core Pure. So method of differences is one which allows us to simplify some series. And then we also have something called the Maclaurin series, which is essentially your introduction to what we call power series. Very powerful tools that are used in quite a few different fields in mathematics. And this introduces that, a very easy power series called the Maclaurin series. And it allows us to express complicated functions as polynomials, or if you want the full extension, then it'll be an infinite polynomial, which isn't actually a polynomial at that point, but yeah, we can describe it as an infinite polynomial. So yeah, that's quite an interesting topic, and we get to see curves converging onto other curves, which is quite nice, quite satisfying to watch. Then we've got some hyperbolic functions. So these are new, brand new to the A-level in further maths. Essentially, it's like trigonometric functions, but less complex. So we take the complex numbers out of trig, which you don't know are there up until this point. So we have hyperbolic cosine called cosh, and then we have sine or sinh, and then we also have tan or tanh. So I delve into all of those. Quite interesting functions that are used to also represent some physical quantities as well, but we do study it very much with our kind of pure goggles on, so we don't have much application to those. Okay, and after that we've got some further calculus. So we take the calculus that was taught on the A-level mathematics course, and we delve quite a bit deeper into calculus. There's quite a bit going on in this chapter. And I think actually on my channel I've split it into two sections. So I've put volumes of revolution, which this one was also taught in year 12, year 1 core pure, but we apply some more complicated integrals to those. So volumes of revolution. We've got something called an improper integral. So there's two types of improper integrals. So we look at those on this course, in this chapter. Then we've got lots of new integrals, so lots involving kind of arc sine, an arc cosine, an arc tan. So there's lots of kind of inverse trig functions kicking around, and then we also have the inverse hyperbolics. So they go straight in from this chapter, and they're used straight away in this chapter. So r sin x, r cosh x, and r tan x. These functions are used to help us solve some more complicated integrals that you can't necessarily do on the A-level mathematics course. So it does get quite difficult. There's quite a lot to kind of remember, and quite a lot to be able to know what to do when and why in this chapter. And then we do wrap it up with some integration with partial fractions, which again was taught at A-level, just a standard A-level course. However, we start to include kind of these functions in the partial fraction results. So you get these integrals in partial fraction questions. So that's the calculus section. Oh, you also got the mean value theorem. I don't know why that's in the further. It's just divided by the interval. Mean value theorem, nice and straightforward. What's the average y value over an interval? It's just a comment, really. And then on to my favourite part of mathematics is the differential equations. So you met differential equations in, again, A-level mathematics. The only method you learnt was what's called the separation of variables method, which is where you take the dx and put it on one side, and dy put it on the other, and then you separate the x and the y, and then you solve that differential equation. That's the only method you need for A-level mathematics. For further mathematics, you meet two new methods. So we do approach this one, but with some of these integrals, so that'll feed straight in. We also have something called the integrating factor method, a very, 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 very clever little method which makes use of reversing the product rule for differentiation. So that's quite nice, nice topic. And then we have the auxiliary equation method, which is quite in depth, really, because it has lots of kind of different possibilities, whether the auxiliary equation roots are real or complex or repeated, or there's lots of different options and lots of things going on. So there's lots of kind of little nitty-gritty bits to remember within that. So it can get quite cumbersome, but once you've battled through that content and got it in your head, it actually makes a lot of sense, and it is fairly easy to retain in your head once it's there. It's just getting it in there in the first place can be quite tricky. And then to wrap up differential equations, we do look at some applications of differential equations as well. So this is kind of as close to applied maths as you're going to get in a core pure exam. Most of it is just maths for the sake of maths because it is a pure paper, but we do have a little bit of application in differential equations, which includes simple harmonic motion, which uses the simple auxiliary equation method to solve, damping, which you might come across in physics as well, critical overdamping and underdamping. And then we also look at population or systems of differential equations, which predator-prey population systems can be modelled with those. So we do look at that briefly as well. I love this chapter. This is going to be one of my favourites. I've spent a good bit of time going over those videos and making sure they're good. So by the time you get to differential equations, my video skills are a lot better than they were when I first started videoing. So hopefully that will be of use to you. And then the final section at the end of my course here is vectors. This can be quite a difficult topic because it's all in 3 dimensions. We look at something called the cross product of 2 vectors. I define it from the basic definition, and then I prove results using it, including areas and volumes and things. And then you have some kind of, occasionally some application questions, again in vectors as well as differential equations, where you might have a line which represents a tunnel through a hill or something. And you've got to find shortest distances between lines, shortest distances between points and planes, and where things intersect, if they intersect, etc., etc. So there's kind of lots going on in there, and it's quite hard to visualize because it is all 3-dimensional. And then the diagrams they give in an exam aren't massively great necessarily because they're 3D, and you can't like put it on a computer screen and scroll around or whatever. So vectors can be quite a difficult topic, but yeah, it's all covered on this channel. So I'm just looking over my notes for this video, just to make sure I've not missed anything off. I don't think I have. I'll just show you my notes. It's all kind of squiggly. So complex numbers. Then got polar coordinates, further series, hyperbolics. We do some calculus on hyperbolic functions as well. So differentiating sine and cosh and than and integrating them. Yeah, I mentioned volumes of evolution, inverse hyperbolics, radical integrals. That's quite a good topic there. So integrating things like the square root of x squared plus 2x minus 5 or something like that, which you can't necessarily do using A-level methods, or you might have perhaps an integral which is x squared plus 1 to the power of minus 3/2. The x that could be quite hard integrals, and you need to know what to do based on where things are, what powers are, and what signs things are. So there's quite a lot to remember in there. Polar coordinates, yeah, got some definitions, look at some curves, do some calculus to find some areas and things. Differential equations, separation of variables, integrating factors, non-homogeneous ones, which that's all explained later. Cross product distances, yeah, that's everything that's on this course. So that's what this course, this section is all laid out. Core Pure Year 2 is what it's called. It's about 70 videos long or so, and it covers the compulsory part of the A-level in Further Mathematics. And as I said at the beginning, we do focus a little bit more on the MEI specification compared to the others. That's just because of what I teach in the school that I work at. All right. But yeah, fantastic. Any questions, drop them in the comments, and I hope you find this course and the rest of my channel useful for you.